welcome again. Back so soon. Here we go. Classwork 9.1. Going to do a sampling of problems. We're going to be doing number 3, 7, 17, and then 23. Working on area. Alrighty, and then it's showing us how just the different applications of area. Not always just plugging into the formulas, but we have to kind of use our reasoning. Man, we got to think. All right, Jesus help us. All right, so I'm going to start with number 3. Number 3 says we have to find the perimeter of a square that has an area of 169 centimeters squared. Okay, so notice again, perimeter is the distance around a shape, like if I was going to walk around this square, and they've given us the area it covers. So if I want to know the area around, obviously I want to know the side lengths. Now, of course, they're not giving me the side lengths, they're giving me the area. But again, because this is a square, we can work backwards to find our side lengths and then find our distance around, or perimeter. So the first question is to realize, how did they get the area of a square? Well, area of a square is simply the sides times the sides. It's base times height, but the unique thing about a square is that the sides are all equal. So we call that sides times sides, or sometimes it's just written as area equals side squared. So that means, going back to what I did in the homework, if I want to solve this, again, if you can't just intuitively do it, I'm here to help and walk you through it. The area is equal to 169 equals the side squared. So now I have a formula, and I'm trying to find the side, so now I can just work backwards algebraically. The opposite of squaring s would be to square root both sides. So that tells me that then the side by itself, before they multiplied them together, was simply the square root of 169. The square root of 169, therefore, is 13. Okay, so 13. Now, that's not our answer, but now we know that this square is 13 by 13, which makes sense, because if I was going to find the area of a square, I wouldn't even need to know, I just would know just one and say, okay, 13 times 13 gives me the area of 169. Now, however, we're doing the perimeter. Perimeter is distance around. So that means if I went here, 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 I'd cover that distance of 13 4 times, because that's the distance all the way around. So to find my perimeter, I'm just going to do 4 times 13, because I'm again walked here, 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 and here. All right, and so that means my perimeter is 52. 4 times 13 is 52, and then our units were centimeters. Quick little bonus information. This is perimeter, so it's not centimeters squared, because I'm not covering an area, a block of area. I'm traveling a linear distance. So perimeter is always plane units, whereas area is always square units. Okay, so again, notice we had to work backwards from the area to find the lengths, and then use those lengths in a new way to find the perimeter. That's the kind of processes you're going to see throughout, I think, Chapter 9. It's going to make us really mentally flexible. It's good exercises. Okay, even though sometimes we hate to exercise. All right, number 7, the area of a rhombus. Okay, and if you remember, and again, they're going to make us work for it. Very simply, they would say, because the area of a rhombus is area equals, do you remember? 1/2 diagonal times diagonal. Diagonal 1 times diagonal 2. If they made it really easy for us, they would just give us both diagonals. We look at our picture, we can see, oh, they gave us one of the diagonals. How nice of them. But we do not know the other diagonal. So that means they must given us a piece of information to allow us to find this diagonal. And something you're going to see come up, I think, throughout several of these problems, and probably throughout this chapter, is our tricks for finding our distances within triangles. Because I can see this here is a side of a triangle. And so let's take a look at this smaller triangle, because they must have given us this 25 for a reason. And I can see this is a right triangle. So and I know that this is 25, do I know this distance? Well, I know the entire thing is 14. And if we remember back, rhombuses, diagonals always cut each other in half, bisect each other. So if the whole thing's 14, you guessed it, this piece just here must be 7. So I have a right triangle with a hypotenuse of 25 and one of the legs of 7. How do I find the other leg? Pythagoras, that's right. So we're going to have to use, and you're going to do this a lot, so that's why this is a good one to demonstrate. You're going to use the Pythagorean theorem to find this missing leg here. So we've got a squared plus b squared equals c squared. So this formula is just going to have to wait on hold for a minute. I'll go ahead and jump down here. Pythagoras, a squared plus b squared equals c squared. So I've got, let's say, a squared plus 7 squared equals 25 squared. All right, so then we keep working. A squared plus 49 equals, I'm just going to confirm, 25 squared is 625. So now how do I get my 625 or my a squared alone? Let's subtract 49. So I'm just going to do this carefully on my calculator over here. 576. So a squared is equal to 576. Okay, how do I undo squaring? Just like we did in problem number 3. All these skills come in handy dandy. We're going to square root both sides. So that will simplify it, and I'll get just this leg here. A is equal to the square root of 576, which is 24. Notice when I found the side here, I wasn't done. I found A. That's not the final answer. If this was a quiz or test, I wouldn't want to just, oh, 24, quick. No, you'd be jumping the gun. All we did was find out that this right here is 24. So now we need to go back and say, okay, I need to know my diagonals in order to find the area of this rhombus. Well, one diagonal, let's go ahead and start to fill this in. Area equals 1/2 times one diagonal was 14. And the one I just found, was it 24? Nope, be careful. I found this to be 24. So what's the entire thing that's been bisected? Twice 24, which is 48. So unfortunately, or I will say fortunately, because I believe in you guys, a lot of critical thinking is necessary in these problems. You got to be neat and work your way carefully, because there's all sorts of places where you could go astray, and it's why it's a great last chapter for us to cover, because you're combining a lot of different skills. And so you got to think carefully each step of the way. Okay, so now we have our two diagonals, 14, and when we found this out to be 24, that means this must be 48. So now we just need to crunch that number. 1/2 times 14 times 48. You can use a calculator. I don't care. Save some brain energy. The way I like to do it is I usually take this and I simplify one of these numbers. I usually do 1/2 times 14 is just 7. And so 7 times 48, which I'm still not super fast at doing in my head. So I'll just plug it in. 48 times 7 is 336. And I'm pleased to see that is the right answer in the book. 336 inches squared, because now we're in area. So the area of that rhombus is 336 square inches. So notice the issue that we're going to finding the area, but they're giving us incomplete information. So we have to use another skill to fill in the information we're missing. Thing you'll be doing a lot of is Pythagorean theorem. We're going to be doing it again here in problem 17. So this is a very important tool you're going to be using again and again. Let's take that now and apply it to 17. Just going to turn the page of my textbook. Okay, now this one could scare you because there's a radical, but that's all right. We'll put on our big boy, big girl pants, and we'll be okay. Jesus will help us through the valley of shadow of death. So we're trying to find the area of a kite. We've got our kite here. Oh, let me finish drawing it. And draw this last part here. Okay, and again, the kite, our formula, is simply, I'm going to try to leave us lots of room to work. A equals 1/2 d1 times d2. All right, so we need our diagonals. And what we can see, they've indicated this is red here. So they've given us half of this diagonal. That's correct. Yes, they've given us half of this diagonal and none of this diagonal. So what are we going to do? Well, you can see when you start adding diagonals within quadrilaterals, you get all these beautiful right triangles. Okay, so we're going to have to repeat what we did in number 7 and use Pythagoras to find these dimensions. Do I know what this is? Yes, I do. This is 7. The shorter of the two things, of the two diagonals in a kite, are always bisected. So I know that this down here is 7√3. So this is all 14√3. I'm going to go ahead and write that in just so we can remember that. A equals 1/2 times 14 square root 3. But we need to find this diagonal. And we're going to have to do it in two different pieces. If we look, I have a right triangle here, of which I can find this piece. And these are clearly not equal. So then I have another right triangle here so that I can find this piece. So let's start here. All right, and it's exactly the repeated process we did up here. I've got the hypotenuse, 14 squared. Let's see, maybe I can do it right here. 14 squared equals 7 root 3 squared plus b squared. A squared plus b squared equals the hypotenuse squared. Okay, so we're going to go ahead and just crunch those numbers. There's some tricks to do this in your head, but we're just using our calculators while we concentrate on harder concepts. So this is 196 equals, and you can put this right into your calculator, 7 root 3 squared. If you're doing it in your head, it's basically 3 times 49. Whoops. So this is 147. 147 plus b squared. So now to get b alone, just like we subtracted the 49 up there, we're going to subtract the 147. Okay, and we get, how exciting. Oh, wonderful, we get a nice squared number. So these cancel out, and we get 49. Oops, I can write correctly. 49 equals b squared. And simply now, once you get good, you don't have to show all these steps, but I'm trying to be helpful. So b is 7. Square root of 49 is 7. So I now know this little piece here is 7. So we're halfway home. We're just going to repeat the same process. So we're not using multiple skills here. We're doing the exact same thing twice. I know this leg here, and I know the hypotenuse. I need to find the missing leg. So let's repeat it. Hypotenuse squared, 14 square root 3 squared equals the one leg, 7 root 3 squared, plus the missing leg, we'll call that b squared again. And now let's work through it. Okay, apply my calculator if you need to. This is just 3 times 14 squared. That's a pretty big number. Let's see, 14 times 14. Oops, that's not the right number. 14. Okay, times 3. So this is 588 equals, I already know what 7 root 3 squared is. It's 147. 147 plus b squared. So now we'll just subtract our 147. Cancels out, and we find out what b squared equals. So 588 minus 147, we get 441 equals b squared. Square root both sides. And hallelujah, it's even again. So I just ran out of room. B is equal to 21. So there we have it. This piece is 21. So again, all we did was use Pythagoras twice to find the information we really needed. We know this diagonal is 7 root 3 twice, and so that's 14 root 3. And now we know what this diagonal is, 7 plus 21. So the missing diagonal that I had to work for is 28. So going back to our original problem, 1/2 times the one diagonal, the vertical one here, times the horizontal one here, and now we can calculate that on our calculator. And so what they do is they leave, well anyway, you'll see they leave the square root 3. We'll do the 1/2 times 14, which is 7, and then 7 times 28. So we get A equals 196 square root 3. They leave the square root 3 out. If you crunched all that and you got 339.5, you're doing it right. But one simple way of when you're working with these root 3s, these radicals, is they kind of treat them like x's and they leave them out. So what they did is they did 1/2 times 14 times 28. And that's where they got the 196. And then they just kept the root 3 there because they know root 3 is an irrational number. So 196 root 3, just multiplying the two diagonals and then cutting it in half. And our units for this problem are inches, so we got inches squared. Bada bing, bada boom. Okay, but notice a little bit of work, takes some space, takes some time. If you make a mistake in here, you're going to input bad information there. All reasons why on quizzes and tests to show your work, because you could be doing a lot of it right, and maybe you did a subtraction step wrong, or maybe you did a squaring step wrong. Don't get discouraged because you're probably doing a lot of it good. You just got to be neat enough to be able to go back and diagnose where maybe you're making a little mistake. Okay, one more. We're going to switch over to the last one, 23, because this is another example of them giving you indirect information to try to find a missing dimension. Because this one's just find the area of a parallelogram. Well, that's pretty straightforward. Area of a parallelogram is just the base times the height. Very simple formula. And we look at what they've given us. They've given us, I'll call that the base. They've given us 10, but here's my height. I don't have the height. Okay. So in that last problem, they used Pythagoras. The last two problems, that's one thing you'll be using a lot. The other reason, if we look, wow, they've given me this length here, and they've given me a degree. Why? Well, let me show you. The height, I can draw lots of heights. These are all heights. And one height would be right here, creating a right triangle that is at 60 degrees. And that 60 should trigger something in your mind that this is a special triangle. 30, this has to be 30 up here, 30, 60, 90 triangle. And don't worry, you'll see this a lot. So 30, 60, 90, what that means is knowing this distance on this triangle and knowing that this is a special triangle, I can immediately find the other sides of the triangle because I've memorized my special triangles. If you remember your 30, 60, 90 triangles, we learned that the short side is x, the hypotenuse is twice as long, and then the longer leg is x root 3. All right? And so we can see what they've given me. This 6 represents the hypotenuse. So that means this little distance down here is half of that hypotenuse. So that means this distance down here must be half of 6 is just 3. Now, I don't really care about that, except that that x then allows me to know the height very quickly. And that the height of this parallelogram must be this number times square root 3. So the height of this must be 3 square root 3. And that's what I need in order to do my formula. I needed to know what the height of it was. And the way we did that was we knew our special triangle, and we're able to quickly deduce the other dimensions. And that's why special triangles are so powerful. And although you hated memorizing them and working on them, they'll save you so much energy because you can see how quickly I did that if I knew how that, what that 60 represented. So now we have our base and our height. And I'm going to solve this before I then mention one other way that you could find that 3 root 3 before I end the video. So I know what I got my area. Area equals my base is 10. My height is 3 root 3. And just like on the previous problem, I'm going to treat this radical separate. I'm just going to multiply these two numbers and leave this as it is. So I'm going to get 10 times 3 is 30 square root 3. And that is your area. Our units for this problem are centimeters, so centimeters squared. So 30 square root 3. And you can usually leave that as a more exact